What's up, periods 4, 5, and 6? Here's some quick notes from 3-5. 0 and negative exponents. You're going to learn about the zero exponent property and the negative exponent property. Giving you kind of a general idea here. Working with a base of 5 and then descending with my exponents, you're going to end up seeing why anything to the 0 power is 1. That's the zero exponent property. Anything to the 0 power is 1. And that negative exponents do not yield negative results. What they do is they create, that negative sign in the exponent creates the 1 divided by idea. So, looking at this table, you would see that 5 cubed means 5 times 5 times 5, or 125. And that 5 squared repeats the base twice. Well, 1 to the 5th only repeats that base 1 time. Now come over to the products. 5 times 5 times 5 is 125. 5 squared is 25. 5 to the first is 5. What's the pattern? What's going on? Well, I'm just dividing by 5. So what would 5 to the 0 power be? Well, if I have 5 divided by 5, well, wouldn't that just be 1? So that's just a very simple, that's a simplification of why your answer is 1. If I were to have these notes over here, 2 cubed is 8, 2 squared is 4, 2 to the first is 2, 2 to the 0 power, what would that be? So let me write these answers out. 8, 4, 2. Do you see the pattern? I'm just dividing by 2 to get to 4. I'm dividing by 2 to get to 2. 2 divided by 2 is 1. All right, looking at the negative exponents, you will see that 5 to the negative first is 1 over 5, and 5 to the negative second is 1/25. It's really 1 divided by 5 squared, 1 divided by 5 cubed. Looking over here, 2 to the negative first, I would get 1 divided by, boy, that's ugly, 1 divided by 2. We know that 2 squared is 4, so 2 to the negative second is 1/4. And 2 to the negative third, well, I know 2 cubed is 8, so 2 to the negative third power is 1/8. So take a quick snapshot of that. Moving on. On 3-4, we know that if we divide by the same base, we can subtract the exponents. And that 4 to the third minus 3 is 4 to the 0 power. And I just got finished telling you that anything to the 0 power is going to be 1. It is not 0. Just a different take on the problem. There's a different method. Remember, there's more than one way to skin a cat. So I'm just showing you why the answer is 1. Why you get to subtract your exponents when you're dividing by the same base. A separate example. If you have an expression that looks like this, the coefficients, anything divided by itself is 1. Well, 18x to the 20th power divided by itself should just be 1. Or 18 divided by itself is 1, and then I take the division property, dividing by the same base, I could subtract my exponents and get 0. Well, that's just saying 1 times x to the 0 is 1 times 1, which equals 1. See those faint circles? I took a big, ugly problem and I broke it up into 3 easier problems. 9 divided by 3 is 3. X to the 5th divided by x to the 2nd. Well, I could subtract the exponents and get 3. Dividing by the same base, I could subtract these 12s and get 0. Y to the 0 power is just 1. Or I could have canceled it here. I could have simplified this right here. Anything divided by itself is 1. Oh, this is the controversial problem. I had students yelling at each other today. Some thought the answer was 1. Others thought it was 5. They got into a big fight about it. It was pretty awesome. All in good fun. That 0 exponent belongs to its immediate base, the x. So because some people saw that exponent of 0, they were saying the whole thing equals 1. But if you recall, an exponent only belongs to its immediate base. So look at the faint circles here. 5 times x to the 0 is really 5 times 1, which equals 5. Just a different way to see that 8 to the 3rd divided by 8 to the 5th, I expanded and then canceled or reduced, and I wound up with 1/64. If there was any problem to really pay attention to, it would be this problem, as I'm showing you a different method. It's same exact problem, look up above, same exact problem, but instead of expanding, I use the rule that dividing by the same base, I subtract the exponents. And notice that 3 minus 5, that difference is -2. So here I'm showing you, where's my finger? Right there. 8 to the -2nd power. That little negative sign becomes 1 divided by. The 8 squared becomes the denominator. Hopefully you know that 8 squared is 64. So 8 to the -2nd is 1/64. Here's an example of that. Same style of problem, just a different problem. 2 to the 8th divided by 2 to the 11th is 2. To the 8 minus 11 is -3. And that little negative sign becomes 1 divided by. The 2/3 becomes your denominator, and 2 to the 3rd power is 8. So 1/8. Check the faint circles. How did I show my work? 100 divided by 200 is 1/2. Where do I have more b's, on the top or the bottom? On the bottom. Or you could have done the subtraction of the exponents and recognize that b to the -25th simply goes down here to the denominator. C, where do I have more a's? On the bottom, how many more do I have? 8. The distance between -3 and 5 is 8 spaces, so know that where do I have more a's? On the bottom. Where do I have more b's? On the top. How many more do I have? 5. And where do I have more c's? On the bottom. How many more do I have? 2. This is just a prompt. Truly, you could go through the method of dividing by the same bases, subtract your exponents. This would be a to the -8th. That would just wind up in the denominator. Again, if you have questions, you can always send me an email or ask in class or ask on Interconnect. There's more than one way to do this problem. This is the way that I chose to do the problem. I did power of a power rule, where this exponent belongs to all the base's exponents inside the parentheses. Notice that some of my exponents are negative and that their bases and the positive exponents ended up, This is incorrect, folks. Where's my pen? 2 and 4. By the way, if you ever catch a mistake on my notes, I will give you extra credit for that. My error, my loss is your gain. Okay, if you wanted to look at the textbook, here is the work. Feel free to push pause at any time. Still a good idea that if you're trying to figure out how to do these problems is continuing to watch this video. Ooh, my favorite problem is number 8. You should have skipped all of this work. Anything to the 0 power becomes 1. If your outermost exponent is a 0, just skip to the answer. I really like number 9 as well. That's it. That was 3-5 in under 12 minutes.